So again, with that, Roger Pielke Jr. is here to discuss the Great Reset, making sense of climate and energy policy in a time of uncertainty, and he's going to cover a lot of very current issues for y'all today. Thank you, Roger.
All right. Thank you. Thanks, Kirby. It's great to be here. First thing I want to say is thanks to all of you. I've been here for about the last 24 hours, and whenever I come to events like this, I feel like I'm engaging in highway robbery because I think I'm taking away a lot more information than I'm providing. Second thing I want to say by way of introduction is I'm from Colorado. I grew up in Fort Collins, live in Boulder. I was on the faculty at CU Boulder for 24 years. And I'm lucky, I'm privileged in my work. I get to travel all over the world, meet with people. But there's nothing like going to a big event in my home state with my people. So thanks for that. It's been great. So when Kirby contacted me, 6 or 8 months ago and invited me to come, he said, do you have any thoughts on a title? And at the time I said, well, boy, I really don't want to give you a title because who knows what's going to happen in the world between now and when I talk. I think if you would have asked me that same question like 3 weeks ago, I would have had the same answer. So what I'm going to do today, and so this is, you got a professor with a PowerPoint. You guys are a captive audience because you got your meal in front of you. Sit up straight, have a sip of your coffee. This is going to be a little bit like if you saw The Matrix when Neo learns how to fly the helicopter. That's kind of the style of presentation I give. And I want to leave some ample time so that we have an opportunity for discussion and questions. All right, I'm going to start. So at this moment, probably in my 30 plus years of working in climate and energy policy issues, this is one of the most significant moments of change that I can recall. This is a quote from Paul Ehrlich, 1975. He wrote the book, The Population Bomb. Paul Ehrlich passed away at the ripe old age of 93 last month. He said, in fact, giving society cheap, abundant energy at this point would be the moral equivalent of giving an idiot child a machine gun. There has been this view in academic and environmental circles that the consumption of energy is a bad thing. More means more bad things. Things have changed. This was in Bloomberg yesterday. This is Tim Hodgson, the Canadian Minister of Energy. What is very clear to me today is there is a very large percentage of the human population that doesn't want to make the trade-off of economic growth for lower carbon. It was in an article by Javier Blas, one of the greatest journalists covering energy these days. The title was How to Make Drilling for Oil Woke Again. I'm not sure what that means, but there is this sense out there that the world has changed, and consuming energy, producing more energy, is a political priority across the board. So what I'm going to start with, and I'll end with this same slide, and I'm going to go through a lot of data and a lot of slides, is I'm going to suggest how we collectively might talk about energy and climate change in 2026. I've noticed over the years that engagement with folks in the energy industry, particularly in fossil fuels, there's been a sense that, well, we must be the bad guys, because that's what we're being told from the climate movement, from the academic movement. Just stop oil, big movement in the UK. And I'm going to say things have changed. And that what I'd like to do is recommend some ways to talk about energy and climate change in 2026. And I fully endorse from the last two panels talking about the need to get out and talk with people to improve energy literacy out there. What I'm going to suggest is that the discussion that we should be having is fully consistent with the consensus center of scientific understandings. There has been this sense out there that there are climate skeptics and there are the climate believers, and folks in the fossil fuel industries are on the wrong side of that. And what I'm going to share with you today is actually, you sit at the center of where the scientific consensus is, and I'll share what that means. And that has changed over recent years. Reflective of the turn to energy pragmatism. Somebody said it well in one of the earlier panels. People expect the lights to come on. They might not know where the wires go and wind up, but people want energy that's affordable, reliable, In many places around the world, they want it accessible. Most people don't enjoy the sort of energy services we enjoy. I'm sure Arjun talked to you about that. And then I'll present some results of a survey that Rui Teixeira and I did at AEI. Most Americans are in the fat part of the bell curve. They're politically grounded. They reject polarization. They're very pragmatic. So with that, I'm going to give you 8 points. This is the buckle up part of the conversation. I'll go through with these 8. Let me say at the outset, there is a lot of data in this presentation. If you want my slides, I'm easy to find. I'll have my contact information at the end. I'll also say each of these 8 points could be its own week in an 8-week semester course. So there's a lot of stuff to discuss and go through. All right, so number 1. So climate change is real, and it poses risks. This is a graph that shows accumulating heat content of the oceans. Since about 2000, there have been a series of floats that are deployed in the ocean called Argo floats that measure the temperature of the oceans around the world down to 700 meters. And you can see that line goes up. There are a lot of arguments about atmospheric temperatures and whether they're measured properly and urban heat island effect. For me, the most compelling evidence for the human influence on climate is in the oceans, not the atmosphere. I will say, I have not really viewed the science of climate change to be controversial. I had the privilege of growing up in a household where my dad was a leading atmospheric scientist. He was the Colorado state climatologist in the 1980s. He's still kicking around, still doing climate research. So the debate to have is not about whether humans affect the climate system. We do in profound ways, not just carbon dioxide. But there are legitimate questions to have about, well, what are the risks? What's the magnitude? And what should our priorities be? I'm going to argue to you that smart energy policy really doesn't depend on what anyone actually thinks about the science of climate change. All right, number 2. So after decades of warming, most types of extreme weather show little or no detectable change. And you don't have to take that from me. I started working at the National Center for Atmospheric Research in the 1990s on extreme weather, and I've studied it and published extensively, but don't listen to what I say. Just go to the Intergovernmental Panel on Climate Change. It's an international assessment body established in the late 1980s, which every decade, 7 years, produces a big, thick 10,000-page report that nobody except nerds like me read. This is their conclusion. I'll just go through some of the details. So what this figure shows, I'm going to walk over here. This is from chapter 12, figure 12.12. What it shows is whether there has been detected emergence of a signal of change caused by humans in different climate phenomena. You can't read those little letters, but if it's shaded, that means they've detected a change. So heat waves, for example, there has been a detected change. There's more heat waves. There's a lot of certainty, and that's caused by human effects. The second column, with all those words there, are the phenomena for which there has not been detected change. Hurricanes, floods, tornadoes, hydrological and meteorological drought, winter storms, and so on. The last 2 columns show expectations for will we be able to see that signal of change by 2050 in this column and 2100 in this column. And the thing I want you to take away from that is most of those entries are white, empty boxes. The reality is if you're looking for signals of human-caused climate change, extreme events are probably the worst place to look. Why is that? Because there's so few of them. By definition, they're extreme events. Every year, there's something like 60 to 80 tropical cyclones on planet Earth. We measure temperature everywhere in the world, every second of the day, all year round. There are literally billions of measurements. That's why temperature, it's a lot easier to detect signals. Think about it like this. If we're playing poker, and I slip an extra ace into the deck, how many hands, say 5-card draw, would you have to play before you had some statistical confidence that there was an extra ace? Ace is an extreme event in playing cards. You'd have to play an inordinate number of hands to get some statistical certainty. So we're in this situation where the science is very clear. There's a strong consensus on what extreme events say, but the advocacy and media environment has gone in a completely different direction, and we could talk about that also. So I'm going to give you an example. Hurricanes. I started a postdoc at the National Center for Atmospheric Research in 1994 to study Hurricane Andrew, which came through in 1992, and I've been studying them ever since. So right now we're in tornado season. I'm going to write a bit for tomorrow about how each season has its media favorite to link with climate change. We're in the tornado phase right now. In late summer and fall, it's hurricanes. So CNN, every hurricane this season was turbocharged and made more intense than it should have been. Well, here's the data. At the top, it shows the landfalling U.S. hurricanes, just the count of them. If you can see that red line, that's the trend. There's no trend. Since 1900, 126 years worth of data. On the bottom are the intense hurricanes, category 3 and stronger. Again, no trend. The most notable aspect of that time series is that white gap from 2006 to 2017, where there was absolutely no intense hurricanes that hit the U.S. I talk to people in insurance, I talk to reporters, talk to policymakers, and they say, I think back over the last 20 years, we didn't used to have intense hurricanes. And now we do. And I say, well, you're right. But guess what? 20 years is not a climate record. So anyone's lived experience is not enough to demonstrate change. This goes back to 1900. There are records that go back before that. This is another metric. This is globally. So hurricanes that hit the U.S., it's a small number. This is what's called accumulated cyclone energy, ACE. This is a record that's kept by Phil Klotzbach at Colorado State University. It is kind of interesting that CSU is one of the world's leading places to study tropical cyclones at 5,300 feet. But that goes back to Bill Gray and folks in my dad's department back in the day. But this goes back to when we had good satellite measurements in the 1980s, and this integrates both the frequency of storms and their intensity. So it combines those two measures, and there's a lot of ups and downs globally, and the red line shows the trend. No trend. So extreme weather has become a public relations battle. On the left here, I have a statement from NOAA, fantastic federal agency. It is premature to conclude with high confidence that human-caused increases in greenhouse gases have caused a change in past Atlantic Basin hurricane activity that is outside the range of natural variability. So that's a lot of words, but what they're saying is things fluctuate, and we haven't been able to detect any trend in the context of those fluctuations. And yet the media jumps on every extreme event, and that's fueled by the fact that extreme events have become kind of the center of advocacy for decarbonization and action on climate change. I'm a big fan of decarbonization. I'll explain why that makes sense in a few points ahead. I'm not a big fan of misusing science to pursue political goals, which is what we've seen on climate change. The economic damage, so the impact, what people actually feel. There's a discussion about rising insurance rates. My rates have gone up. I'm sure many of your rates have gone up. It's a little known fact that the insurance industry the last several years has had their record profits. Insurance industry doesn't do a lot to fuel the discussion of climate change, but they sure do like it. This is the cost of extreme weather events, the total cost worldwide, going to 1990, when we have good records, as a proportion of the global economy. So yes, costs are going up associated with extreme weather. That's because we have more people, more wealth in exposed locations. Once you normalize that for the changing size of the economy, again, there's the red line. It's not statistically significant, so no change. There's no indication that the economic effects of extreme weather are going up as a proportion of the economy. All right, number 3. 2025 global disaster death rates were among the lowest ever recorded. This is a fact that not most people appreciate. These graphs show estimates. They're very round numbers, but how many people died worldwide from extreme weather? Turns out the 1870s were one of the most violent decades in recorded human history for extreme weather. there was a big El Nino event, like maybe we're going to see this year, 1877 to 1878, and estimates are something like 50 million people died worldwide. And again, this is a world of about 1 billion people. And so this was about 4% of global population died in that decade. The next much smaller bars, the 1920s, 5 million people died, a lot. 1970s, 500,000 died. And in the 2020s, maybe 50,000, maybe more. Last year, in a round number, about 10,000 people died from extreme weather events all around the world. It is a remarkable accomplishment. I have a paper that I cite often of deaths in the Indian Ocean basin from cyclones in the 1960s. And every year, it's just tragic. 130,000, 70,000, 27,000. It was remarkable how well the world has done with respect to extreme weather. I have some numbers in red here. It just shows death rates to take into account population. In 2025, it was about 0.8 deaths per million people. Well, in 1960, it was 320. 1970, it was 80. 1980, it was 3. 1990, it was 1.3. Since 2000, 6 years have occurred with less than 1 death per million, all since 2014. We are in an era where the random human being on planet Earth has never been more safe when it comes to exposure to extreme weather events. But you might not know that. All right, deep decarbonization will not be achieved by reducing or limiting economic growth. In fact, it can only happen in the presence of growth. It's an iron law. I wrote a book in 2010 called The Climate Fix. I had this phrase in there where I coined this term an iron law, and it was kind of a warning to climate advocates and to policymakers. If we create a situation where economic growth is in opposition to emissions reductions, guess what's going to win? Economic growth. Just like that comment I had from the Canadian energy minister up front. However, and I see this just in the previous session, Michael Bennett is proposing the cap and trade program. Cap and trade, like a carbon tax, is a plan to impose higher costs on the production of certain forms of energy with the idea that you'll make other sources more favorable. Now, if you go to the economics department of a university, they'll say, yeah, that's solid. That's right. If you make something more expensive, people will prefer something cheaper. But if you go next door to the political science department, they'll say, yeah, if you make things more expensive, people are going to get pissed off and they're going to vote for the other guy who promises less. The iron law tells us that politics rules, and people seem to like cheaper goods, cheaper fuels. The climate movement has been going in reverse a bit. So this is Greta Thunberg from Stockholm, Sweden, who was for a brief moment, maybe 7 or 8 years ago, kind of the face of the climate movement. She's moved on to other issues. But what I want to show you is this graph, which shows the view of Swedish girls and boys. The girls are pink and the boys are blue, thinking that climate change is the most important issue. And as Greta Thunberg has moved on to new things, so has most of the young people in Sweden. If you lose the Swedish girl vote, you're in trouble. This is some data on climate change as a top worry for some top population countries. You can see them by their flag if you can't read their names. And this just shows the change from 2019 to 2025. And all you need to see on this graph is that the red bar shows that climate change has decreased as a priority. So in a few places, South Korea, Japan, and Italy, there's been an increase from a very low base. But across the board in India, Sweden, Australia, United States, Canada, Great Britain, Germany, decreased concern about climate change. So we did a survey at AEI, American Enterprise Institute, right before the election, 2024. And one of the questions we asked, and this is asked across surveys over time, and we surveyed, and I'll show some more data from this in a second. We asked American citizens, how much would you be willing to add to your monthly utility bill to combat climate change? And the first one is a $1 fee. And that got a majority support. 47 to 43 of people who thought they would vote for it. Once we got to $20, support cratered. 60 to 26 against. $40, $75, $100. People care about the climate. People support action on climate change, but they don't want to pay for it. And so this is a design criteria that I think policymakers need to appreciate. This is a more recent poll. So this was done at the end of last year by the University of Chicago. And it was the same question. Would you pay $1 more on your electricity bill to combat climate change? So in 2021, they had results very similar. Ours were 47%. They found 52%. 2025, that dropped to less than a majority. So this is from our poll. This is what I think is the most interesting result. So we asked people, what's your view on energy and climate policy? And we had a rapid green transition, all of the above, stop the push to replace oil and gas. And overwhelmingly, an all of the above energy strategy was favored. I'm going to show you how overwhelming that view actually was. This other figure, we asked if people want to phase out coal, natural gas, oil. Only 29% did. 71% did not. So this is the crosstab. You can't see it, but this is every demographic group we looked at. Education, are you married? How old are you? What's your education? What's your gender? What's your age? And this is that question. This is the all of the above question. And all of the above is in the middle. Every single demographic we polled had more than 55% support for all of the above. Now, all of the above doesn't mean every technology implemented all the time, everywhere, all at once. It means that every technology has a place somewhere. And if I was advising a generic politician, Democrat or Republican, on how to talk about energy policy, I would start with all of the above. Because guess what? You're going to get the most people in your camp at the outset than any other framing that you could have. Interestingly, I don't think it has anything to do with our poll, but I'd like to think that it does. Democratic politicians, particularly on the East Coast, started talking about all of the above. And now all of the above is kind of spreading through climate and energy discussions. All right. If you only remember one thing from my presentation today, it's this number 5. This is the most important one. So sit up, drink, get a sip of coffee. The scenarios that dominate climate policy were never meant to predict the future, and they're increasingly out of sync with reality. Everything I'm going to show you in the next couple slides is broadly understood and broadly accepted across the climate science community. I call it the best kept secret in climate science. So the way that scientists project future changes in climate doesn't start with Earth system physical models. It starts with scenarios of the future. Because if you want to project how climate might change, you have to know something about how much carbon dioxide we're going to put into the atmosphere going forward. To know that, you have to know how many people will there be? How big will our economy be? What are our energy sources going to be? How are we going to consume that energy? And so those scenarios feed into those models. So back in 2005, there was 1,184 different scenarios that were available to the climate science community projecting the future. On the vertical axis, you have emissions from the burning of fossil fuels. This is 1990 to 2100, and these are different scenarios of how much we might emit. You can't really do research with 1,184 scenarios, so the community standardized those scenarios into 4. This very high one, RCP 8.5, one closer to the middle, RCP 6, RCP 4.5, RCP 2.6. Think of it like this. This is basically stabilizing climate at 2 degrees in 2100. This is something more like 5 degrees. The community made a big mistake back when they established these scenarios. They said, well, this one, this most extreme one with 5 degrees Celsius temperature change in 2100, that's where we're headed. That's business as usual. And this one is policy success. Just to flash forward to where I'm going, we now know that this was never plausible. The world was never heading in that direction. Why not? That scenario assumes that all of our energy is going to come from coal. All of it. Natural gas, going away. Nuclear, going away. Gasoline? No, we're going to get liquids from coal. Wind, solar, none of that. It's all going to become coal. Coal is obviously the most carbon-intensive fossil fuel, twice approximately as carbon-intensive as natural gas. So this is a coal-fueled world. We're not headed there. Where we're headed right now is somewhere south of RCP 4.5 on what's called current policies. So we did some research with Matt Burgess, who's at the University of Wyoming now, and Justin Ritchie at University of British Columbia. We took those 1,184 scenarios and we plotted them as dots on this graph. We have projected temperature change to 2100, 1, 2, 3, 4, 5, and then we have the cumulative amount of carbon dioxide that we emit from the burning of fossil fuels. So the first thing to take from this is, well, yeah, look at that. You have more cumulative carbon dioxide, more temperature change. That's pretty well understood. To be included in the scenarios of the Intergovernmental Panel on Climate Change, they state they have to be plausible. They have to be possible of occurring in the real world. So since they had all these back in about 10 or 15 years ago, we drew this red oval to represent the plausible scenarios. In our research, we said, all right, these scenarios were developed in 2005, thereabouts. One question you might ask, I'm not going to answer it in this talk, why is the climate community using scenarios from 2005, not 2020? But that's a different question. We said, all right, from 2005 to at this point, 2022, we have some real-world data on how emissions have evolved. We know something about population. We know something about the mix of energy consumption. We know about how GDP had changed. We also have the short-term energy outlooks produced by the IEA, the EIA, BP, Exxon, the oil majors. And we ask the simple questions. If we compare these scenarios to the real world, both what we've observed and what's projected in the near term, which ones survive? It's a little bit like if we say, all right, there's some weather forecasts for the temperature today. We want to know which ones were most accurate. Well, the ones that say it's 20 degrees outside, we can get rid of those. And the ones that say it's going to be 105, we can get rid of those too. And the ones that are left are the ones that have survived. I'm going to show you which ones survive. This is that same graph I just showed you. The scenarios that survive our test are in this little red oval in our 22 paper. The apocalypse, the extreme scenarios, they fell out. They disappeared. We were among the first anywhere to publish this result that said that, well, it looks like, based on what we understood at the moment, the world is heading for something like a 2 to 3 degree temperature change by 2100, not a 5 degree temperature change. Our central scenario, the one that was most consistent, was 2.2 degrees. If you follow climate policy at all, you'll know that the 2 degree Celsius, nice round number, is kind of the marker for success in reducing emissions. We found 2.2. It's not that 2 degree target, but it's not far away either. When we first published this, there was a lot of debate. We were called climate deniers, and now I'm happy to report pretty much everybody agrees with this. So here's that spaghetti diagram I showed you before. These high-end emission scenarios today are implausible. And the plausible ones are down here at this lower end. The world, as I said, and again, don't take it from me, this is just official UN data. The world's undershooting RCP 4.5. That's a 2.7 degree scenario. So when we talk about climate change, I always emphasize to people, the basic physics are pretty well established. And you can agree or debate or not debate them, but this is consensus science. The scenarios have moderated significantly. The language of existential threat that we've heard. The Biden administration liked to use that climate change threatens the existence of humanity or the planet itself, is just not supported by the science. And I think everyone anywhere should be aware of this change because it's very difficult to find it out there in the public discourse. All right, that was number 5. Number 6, the global economy has been decarbonizing for decades. What do I mean by decarbonizing? This metric, which I think is a very important one to understand, is carbon dioxide emissions over GDP. We want GDP to go up because that means people are getting wealthier. We want CO2 emissions to go down. There's good news here, really good news. The global economy, as well as the US economy, has been decarbonizing since we have data, since at least the 1960s. What is really interesting about this graph, I call it the most interesting straight line graph I've ever seen. It's steadily gone down, this ends in 2024, and there's no indication of an inflection point. So if climate policy is working, the whole point of climate policy is to bend this curve, to make it go down faster. There is no evidence that anything that's been done at the international level, at the national level, has had any influence on this metric. Climate policy does a lot of things, but accelerating decarbonization has not been one of them. This is for the world. If you look at the US curve, it is just as straight a line. We can decompose this into its factors. This is GDP, that's gone up pretty sharply. This is CO2 emissions, not as sharply as GDP, this is population. The factors that shape this curve, most importantly, are the energy intensity of GDP. So how much economic activity do we get for input of energy? That's gone down sharply. And historically, the carbon intensity of energy has really not changed as much. Going forward, if we want to decarbonize the economy, the carbon intensity of energy is going to have to drop a lot faster. That's going to mean the lowest hanging fruit, I'll talk a bit about this, is coal. Replacing coal with natural gas or nuclear, or pick your favorite. I would fully expect that energy intensity of the economy will continue to improve for a lot of reasons, but one is that people like to get more output from less inputs. What I did here was I looked at the 8 years before the Paris Agreement in 2015 for a bunch of countries, their decarbonization rates, and the 8 years after Paris. And then I said, are they accelerating their decarbonization? Those are the green countries, the reds are the ones that are slowing it. Here's the world, no change whatsoever, so these countries cancel out these countries. But if I asked you, who do you think is accelerating decarbonization the most around the world? I gave you a quiz. I don't know if you can read it, but how many of you would have the United Arab Emirates at the top? Then Brazil, then Saudi Arabia. China, which is the big panda bear in the China shop, is gotten more carbon intensive over that time, which cancels out a lot there. Do presidents matter for US emissions reductions? So the US has been steadily reducing its carbon dioxide and greenhouse gas emissions since 2005. Here's another straight line. You can see the global financial crisis, you can see the pandemic. The answer, you can't tell who was president or who held Congress. There is absolutely no evidence that any president has had the ability to modulate greenhouse gas emissions, or Congress. And I expect that's going to continue, despite what Donald Trump might say about this or that policy. Why did this happen? A number of reasons, but the most significant one was cheap natural gas due to the shale revolution, which was the result of both policy and industry. But the policies that were put in place in the 1970s and really bore fruit in the 2000s and 2010s. Number 7. All right, I'm getting closer to the end. So a big story that I think everyone should be aware of are the changing nature of demographic projections for planet Earth going forward. This shows the blue are UN population projections for South Korea, Colombia, and Chile. The red is what's actually happened for birth rates in these different countries. The world is seeing an incredible drop of fertility across the board. In those scenarios of future emissions, one of the reasons that those scenarios are out of date is they project very high levels of population to 2100. Those haven't even been factored in to climate scenarios. More generally, falling population means that we're going to have demands for human beings to do things. Immigration has been a focus in the US and Europe in recent years. My prediction is it won't be long before countries are fighting over immigrants to get them in, because we're going to need more people. This will have implications for social safety nets, because we expect young people to pay for retirees, for people to do basic work. So expect more attention being paid to automation, to AI, to robots, to do all the things that we want to do. The other consequence is that the genius of humanity, part of it is we have so many people, and so we get exceptional talents out there. If we have much fewer people, innovation might be harder to come by. So this is 1950. This is the world, and if you see a country colored in blue, that means that its birth rate is at a level where it's increasing. All right. Now I'm going to show you more recent data with the same question. If it's in pink or red, that means that their birth rate is not enough to sustain their population, which is most places. And this is 2023, and these data are moving fast. And so that's something to pay attention to, because it's going to be a big shift. All right, number 8, then we can have a discussion. Fossil fuels are here to stay for the foreseeable future. And this is data from the International Energy Agency. Because I tell my students, look around. Everything you see, except the flesh of the humans, is made out of fossil fuels. Enormously useful. And this shows oil, natural gas, and coal. Coal is the lowest hanging fruit worldwide for deep emissions reductions. Coal that's burned produces about 40% of CO2 emissions worldwide. For the most part, there are some chemical processes where coal is essential, such as for cement or silica. But for the most part, coal is replaceable with natural gas, with nuclear, to some degree with solar, with batteries. Pick your favorite. There are estimates that the 30 dirtiest coal plants, none of which are in the United States, if they're shut, would reduce global emissions by themselves by about 10%. All right, so this is the gasoline physical intensity of the US economy. I was curious about this when the Strait of Hormuz closed. This is how much gasoline we use per $1,000 of GDP, going back to 1950-ish, and it's steadily gone down. We use a lot less gasoline per unit of the economy than we used to. This is the same for natural gas. It shows a decline, but it kind of plateaued over the last decade and a half. This graph, it takes a little bit to understand, but this is the expenditure intensity. This is the total energy expenditure intensity of the economy back to 1970. Retail electricity, gasoline, natural gas, nuclear, coal, wind, solar, and hydro. Energy overall, it's about 3.7% of GDP, is much lower than it's been historically. So during the energy crisis of the 1970s, it was about 12%. That's why it was an energy crisis. One reason why there hasn't been bigger impacts of the Iran war on the US economy is because our economy is much less energy intensive than it used to be. When it comes to consumers, though, you can tell them, like when I was a little kid, it was 12%, but nobody cares. They think about, well, what was my electricity bill last fall or whatever. All right. So I'm going to conclude, and then we can have a conversation. How to talk about climate and energy in 2026. Number one, stick to the science. That requires understanding the science. There has been this concerted effort to divide the world into skeptics and believers, and nobody pays attention to what the science says. And I encourage leaders across the energy industry, but particularly in fossil fuels, to understand this science and to reclaim the mantle of consensus. You got it. You're not on the outside looking in. You're not the contrarian. You're not the bad guys. Understand the science on your side. One big change that I've noticed for a long time, saw this at my university at CU Boulder, saw this when talking to policymakers. Energy policy came to occupy a subsidiary position to climate policy. Everything was climate policy, and energy policy was a subset. That has switched completely. Climate policy is now viewed as important, but a subset of energy policy, where affordability, access, reliability, security are also important priorities. I will say, it's been about 20 years since Congress considered comprehensively U.S. energy policy in a way that stitches things together. I think we're probably overdue for that conversation. And then remember, this would be my advice to politicians and people who support them. There is a large public consensus in this country on energy policy priorities. People care about the environment, but they care about other things. And if you get into that fat part of the bell curve of what people believe, I really do think there's opportunities for bipartisan action on climate and on energy that moves things forward. All right, those are my 8 points. Sometimes I have talks, I have like 25, so you guys are lucky today. All right, so thank you. Kirby mentioned you can find the Honest Broker newsletter. I talk about all this stuff all the time and piss people off. That's my job. Roger Pielke Jr., Substack.com. I'm easy to find. roger.pielke@aei.org. If you want a copy of my slides, you have any questions, or you just want to be in touch, I'm happy to chat with you. And I look forward to conversing. Thank you.
You're an apparent weather nerd and up over here. Weather nerd and NCAR's employee. What happens if NCAR's gets dismantled, and what do we do to replace that data?
Yeah, NCAR, National Center for Atmospheric Research, was founded in 1960. It's the only structure that was allowed to be built above Boulder. It's what's called an FFRDC, Federally Funded Research and Development Center. It's a place. Think of like if you have a university and you might have an atmospheric science department, and you might have somebody who does middle atmosphere, somebody who does oceans, somebody who does solar influences. NCAR is a place where you have like a group of 30 people for each of those topics. It's a national center of excellence. Number one, I don't know. I worked at NCAR. It's not a perfect place. It could be improved, but it's also not the sort of place you would want to take a sledgehammer to. So my view very much, and I don't know what the politics are, has something to do with Colorado politics and vengeance and things like that, it's not smart science policy. Set aside, and one of the things that the Trump administration said is, well, it's a hotbed of climate activism. There are places that are hotbeds of climate activism. NCAR wouldn't be very near the top of my list. They do weather forecasts. They do things like developing better instruments to sample air pollution and things like that. So my view is that it's dumb science policy. If there are problems with how NCAR is doing its job, then fix them. My big disappointment is that the U.S. Congress hasn't paid any attention to it. It's an important research center. There hasn't been a single hearing. It's not going. It could close, but the functions that it has will go someplace else. And after it was announced, the academic world has politics like everywhere else. Behind the scenes, a bunch of universities were like, "Oh, I'd like, if you're going to cut up that body, I'd like that leg, I'd like that limb. Give me this." There's a partnership with Wyoming for the Supercomputer Center. It would just be moved there. So the functions would probably exist somewhere else, but the strength of NCAR is that you get a whole bunch of the world's top atmospheric scientists in a couple buildings, but together, thinking about really hard problems. And the atmosphere matters to all of us, to farmers, to energy, public safety. So it's not smart policy in my view.
Thank you, Roger. I hail from the southwest part of the state, near Ridgeway, and I think it's all on the back of our minds, weighing very heavily this lack of snow this past winter. It's kind of discouraging, to say the least. But I also look at what's happened over the last 20 or so years, with the drought, and how it really does impact, the hydroelectric generation. We used to consider hydroelectric a renewable, and I don't think we can do that anymore. And I really think we need to be looking at how can we keep the water in our reservoirs before we send it through a dam trying to make power out of it. I think there needs to be more of a conservation effort now. Maybe this is the opportunity for that. I just like your thoughts on what you're seeing.
Yeah, I didn't touch on it in my talk, and it's a really important topic, is adaptation, not just to climate change, but adaptation to climate. The climate is enormously variable, and there are records that go back very far in time. Great Connie Woodhouse, who's a federal scientist, she's retired now, has done great work looking at tree rings, Colorado River Basin. And there are periods of drought like this year and the last several decades extending for many, many decades in the basin. So understanding climate variability, and people like to argue about what's the future we have. What I often say is, well, we know more about the past than the future. Are we prepared for the past? What would we do if we had a stretch like the 1870s or some other period of extended drought? Those are really important questions. And I think a lot of it gets caught up in the discussion of climate change, where the presence of climate variability, climate extremes, is used as a justification to argue about energy policies. I'd much rather talk about things like agriculture, water resources, like you're talking about. I'm glad I'm not involved in negotiating Colorado River Compact things, which was, I'm sure as most of you know, on the wrong foot from the start. But yeah, climate adaptation is a big deal, and water in the West is a huge deal.
Carmia Woolley with the BLM, right back here.
Right there.
So I'm curious, what is the current pulse, with your colleagues or even you? It seems like you largely focused on atmospheric science today. What are the implications for changing oceanic temperatures, and what time scale are folks talking about?
So say more. What do you mean changing? Like the projections for how they will change going forward?
Correct. I mean, that was exactly what you started with. I know I've had lots of conversations about, hey, there's all this stuff, but really this data is showing things. So yeah, what's the current conversation, academic conversation?
The academic conversation is that so long as there's an energy imbalance in the Earth system caused by accumulating greenhouse gases in the atmosphere, the heat content in the ocean is going to go up and up. It's a little technical. Heat content is different than sea surface temperature at the top layer, which affects things like hurricanes and so on. But the expectation is, yes, that warming will continue. And this is why people do emphasize net zero, is because the expectation is the only time where that stops and reverses. The oceans have a lot of momentum and probably will be heating for centuries. But the only time that process stops is when we get to net zero.
Can I add on? I know I'm not technically next. Over here.
I was going to say, that didn't sound like your voice.
But my question is very similar, but I just want to do one add-on. I'm Jane Turner. I work for the city of Longmont. And I was just curious, since you do recognize climate change is real and you've talked about these warming oceans, do you ever think about or try to predict a date at which extreme events might become more noticeable, or something you'd pick up in your normalized data? Or what time frame do you worry about?
There's two things there. One is, I don't worry too much about it because the progress we've shown as a species dealing with extreme events has been remarkable. The second thing is, it's a math problem. So if you take the output of a climate model that says this is how things are going to change, you can say, all right, here's historical variability. When will that signal emerge? And I've studied a few phenomena, but the IPCC has summarized literature on all of them. If you want to have high confidence that humans have changed extreme event frequency or intensity, for most extreme events, it's going to be well past my lifetime. Again, that's the put an ace into the deck. You've changed the deck. There's no argument about whether the deck has changed. But can you notice it in the hands that you play? It's going to be a long time. The other thing to understand is if I snap my fingers right now and carbon dioxide emissions went to 0, you would not see any change in extreme events on those same timescales. And so the idea, I mean, this is where climate policy kind of got off the rails. The idea that modulating energy consumption, greenhouse gas emissions can have detectable effects on extreme events is a consequence of that PR strategy. There are much more profound and subtle changes due to climate change and surprises that might be out there that could affect things like our ability to do agriculture, the chemistry of the oceans, and could have really profound effects. It's a risk management problem. And the idea, I mean, the worst thing that happened to the climate debate was when Al Gore had that hurricane coming out of a smokestack. Hurricanes don't come out of smokestacks. It's not how it works. So I think every community in the world and in this country is at some risk of extreme events. I live part-time in Summit County, and I'm worried my house is going to burn down because everything is so dry, which is why climate adaptation, preparing for extreme events, it's a different lane than energy policy or emissions reductions. So I guess that's a long way to say is I don't really connect those two because there's nothing you can do on energy policy is going to reduce the risk of forest fires in California and Colorado anytime soon. And so we have to take other actions on the ground to make a difference that way. Does that get to your?
Good enough.
Sorry,
Thank you.
right.
And thanks for letting me cut the line.
My name is Lance. I am a LEM student at CMU. And I had an emissions question for you. So I feel like over the past 4 to 5 years, we've been seeing a big push for electrified vehicles because people think that they're better for the environment, but they don't take into account all the ways that we have to extract that material. So all the mining that goes into it, and also other things like commercial flight. So my question to you is, what's your opinions on those sort of overlooked subjects compared to traditional gasoline vehicles as far as emissions?
Yeah, let me, I'm going to give you an indirect answer, then a direct answer. The indirect answer, I just wrote a piece 2 weeks ago about the fossil fuel foundation on which wind turbines and solar panels are built. And so if you look at the International Energy Agency's net zero scenario to 2050, it has massive increases in wind and solar. What it does not do is account for how do we build those? Well, with concrete, with steel, with rare earths. What they do is they assume that all of those technologies we would need in the supply chain would magically appear just in time to produce those with no emissions. And it turns out that I forgot what the number I came up with, but if you actually account for all of the emissions needed to produce those, it's like the size of China. Let me say electric vehicles, I have a plug-in hybrid. I think it's great. Most of my trips are less than whatever the 60 miles range that I have. Last year I filled up twice my car. And there are countries like Australia. Australia in the last few weeks has realized it has enormous vulnerabilities to liquid fuel disruptions. So electric vehicles can provide a lot more security for your economy, emissions aside. There are places like in India where you go around in the little three-wheel tuk-tuks or whatever that run on diesel, often very polluting, can clean the air. There's a lot of compelling reasons, I think, for electrification of the vehicle fleet. For many countries, it's going to be security of supply. But again, like you say, it matters where you get the energy that goes into it. But also, all right, if we have a few billion batteries out there, and these batteries have a shelf life, we don't know how to recycle batteries. There's some promising technologies, like with recycling lithium, but disposing of 1 billion batteries a year is a big project. And so, the only way to make the world better, in my opinion, is through technology, whether you care about emissions or you care about wealth and so on. But doing technology is really hard. And so when my students would come to my classes, they would often treat energy supply alternatives like NFL football teams. Like, oh, I'm team nuclear, I'm team wind, I'm team solar. And I don't know who said it, was in the comments in the last panel on the federal. If we make energy policy a team sport, then we're all going to lose. So there's a great place for EVs out there, I think. A great place for diesel engines and a great place for gas. It just depends on the purposes we have them. So that's a long way to say that I fully expect electric vehicles will grow in their penetration in the market. The technologies will get better. If you have a car that gets 1,000 miles per charge and it can charge in 30 minutes, I bet you we're going to see more EVs. So,
Thank you.
Thank you.
Hi, I'm Dresden Kennard with CGRS, a regulatory compliance consultant. And my question is kind of geared towards all the up and coming scientists in the room. How do you decide where to draw the line between informing policy and influencing policy?
Yeah, that's a great question. I mean, I think if you're informing, you are influencing. I have a whole story I could tell about how I left the University of Colorado. I'm a big fan of academic freedom for academics and scholars, that we should be able to call things like we see them, advocate for what we want to advocate for. Everybody has to go with what they value. I gave you a full-on advocacy presentation today of things that I think should be valued and are important. Where I draw the line is not in the actions of, say, me or any individual. It's between what individuals do and what institutions do. I don't want the U.S. National Academy of Sciences, the University of Colorado Boulder, any university taking on the role of a political advocate. I would liken it a bit to voting. Every academic should be empowered to vote who they want in office. But I don't want institutions taking positions where they say, we endorse this candidate, or we endorse that candidate, or we're going to create a center for the advancement of this interest, which is problematic in academia. Just a quick anecdote. One of the biggest scientific journals in the world is called Nature. It's located in London. They endorsed Joe Biden in 2020. A study was done of that endorsement and found that it led to less trust overall in science, mainly by people that didn't want to vote for Joe Biden. Then in 2024, that same journal, which I remind you is in London, endorsed Kamala Harris, and they wrote an editorial that said, well, it's too important. We know this is going to hurt trust in science, but we're going to endorse her anyway. And so I think our institutions of academia and science have at some point decided they want to be political players. The institutions should exist to inform politicians, leave the politicking and the advocacy to individual tenured professors and so on. The one thing I will say, academia and the scientific community does have a very sharp leftward bias. No secret, I'm not breaking any news here today. If normal people out there across this country, if all they hear from experts is advocacy in one particular direction, then it's not going to build trust in the institutions of expertise anyway. It's not just a right-left split. If you look at declining confidence in institutions of science, public health, there's an education split. People with high school degrees have much less trust than people with PhDs, for example. There's a split between black Americans and white Americans, Hispanic Americans also. The trust deficit has grown pretty much across every demographic except liberal, white, wealthy, highly educated people. If Americans can't see themselves in the experts that are out there talking, they're going to have a hard time trusting.
Thank you.
All right. Well, thank you guys very much.
That was fabulous. Thank you very much, Dr. Pielke.